Comparison based sorting versus non comparison based sorting. The main difference between a comparison based sorting algorithm and a non comparison based sorting algorithm lies in the way these algorithms compare and manipulate the data that is given so as to achieve sorting. So, whenever we talk about any sorting algorithm, the first thing that comes to our mind is we'll have to compare different elements in order to understand which element is smaller and which element is larger so that we can identify the relative position of those elements. So, this is what generally comes to our mind whenever we think about sorting. That is, if we want to arrange in ascending order, we have to compare different elements and see which is smaller, which is larger. Whichever is smaller, that will be placed on the left side. Whichever is larger, that will be placed towards the right side. So this is what generally comes to our mind. But it seems there are some algorithms called non-comparison based sorting algorithms. They don't need to do this comparison. Without this, they can find the sorted order. So in this lecture, we are going to have an introduction about both these types of algorithms. So all the sorting algorithms that you have seen till now in this lecture series are comparison based sorting algorithms. So let us first learn about comparison based and then we'll get to non-comparison based. What is comparison based sorting? In this, elements are compared directly in order to identify the relative order. If you have any two elements in your array, you will directly compare these elements and see which is larger, which is smaller. So you had seen this in all the algorithms that we discussed till this point, be it insertion sort, merge sort, quick sort, anything. In all those, we were directly comparing elements and finding out which one is smaller, which one is larger. And using this logic, we were placing them. Second thing is comparison based sorting algorithms. These work on any data type that supports comparison. If you have any data type, let us say you have integer or you have strings or maybe you have objects. All these data types support comparison. That is, you can compare one string with other string and see in which one alphabets are coming before the other one. And if it is an integer, you can directly compare and see which is smaller, which is larger. So this is how comparison based sorting is done. Most important thing is what is the best possible time complexity of a comparison based sort. We already learned some comparison based sorting algorithms, and from that we know the best possible time complexity is order of n log n. There are multiple comparison based sorting algorithms that can achieve order of n log n, but the best possible time complexity with any comparison based sorting algorithm is order of n log n. Okay. And what are the examples of comparison based sorting algorithms? You have quick sort, then we saw merge sort, heap sort. All these are comparison based, or maybe bubble sort, insertion sort. All these sorting algorithms are comparison based sorting algorithms. Are they stable? Some of them are stable, some of them are not. And the most important point you have to keep in mind is no comparison based sorting algorithm can beat order of n log n time complexity for general purpose sorting. Let us see about non-comparison based sorting algorithms and then let us do the comparison. So in case of non-comparison based sorting algorithms, in this case what happens? How do you identify the relative order of elements? So here the most important point is the elements are sorted without doing this direct comparison. You don't compare any two elements in between in order to see which is smaller or which is larger. You will directly find the sorting order. Then the question is, how do you do this? There should be some parameter which lets you identify that one element should come before the other element in the sorted order. So how do you find this out? This is the next question. So the answer is you use some of the key properties of these elements. So these properties can be value, it can be the range, or any of these properties that can help you determine the position. So when we get into each of those comparison based sorting algorithms, you will get more clarity on this. Exactly what do we use and exactly how do we identify the order. So clear idea on that you'll get only when we reach these particular algorithms. Next thing is the most important part. The most important thing about non-comparison based sorting is these sorting algorithms, they can do better than order of n log n time complexity. In case of comparison based sorting, we saw n log n is the best possible time complexity we were able to achieve. But in case of non-comparison based, in specific cases, you will be able to achieve even order of n time complexity. So order of n log n is no more the best time complexity. In case of comparison based sorting, you can achieve order of n time complexity. So this is under favorable conditions. We'll see what exactly that is in our non-comparison based lectures. So this is the most important point you have to understand about non-comparison based sorting, that is, it can beat the order of n log n time complexity of comparison based sorting. And what are the examples of non-comparison based sorting? You have counting sort, there is radix sort, bucket sort. So all these are examples of non-comparison based sorting. Another point is, are they stable? So in case of comparison based sorting, we said some are stable, some are not. So coming to non-comparison based sorting, it is right to say that it's generally not stable, but the point is you can design these algorithms to be stable. So again, we'll see this point when we reach there. Another point is this works only for those data sets that can be processed without direct comparison. You cannot process all types of data without comparison. For some types of data, you may have to directly compare different elements so as to understand which is smaller, which is larger. But in case of, let us say, integers or maybe strings, in these cases, it is possible. You have a possibility to determine the order without actually comparing elements. So in case of integers and strings, we'll see how we can apply non-comparison based sorting. Okay. So one more thing is, we told that it can beat comparison based sorting and it can achieve a time complexity of even order of n in specific cases. But one more point to keep in mind while talking about this time complexity is that the range of possible values that can affect the time taken by non-comparison based sorting. So in case of comparison based sorting, you really don't care what is the range of elements. You don't care if in your data you have 1, 10, 10,000 or maybe 1 lakh, 10 power 10. You don't care whatever be the numbers, because you are directly going to compare this number with this number. You are going to directly get the answer. But in case of non-comparison based sorting, this range really matters. If you have all numbers in a specific range, let us say all numbers are between 1 and 1000, then comparison based sorting may be done much easier compared to another data set which is having data from 1 to 10 power 10. So this is how I'm talking about non-comparison based. In non-comparison based sorting, this range, that is range from 1 to 1000, may be much more comfortable, much more efficient compared to another data set which is having range from 1 to 10 power 10. So in case of comparison based, you don't care about range, you are simply directly comparing. But in non-comparison based, because you are using range most probably as a parameter in order to identify the different data sets, the position of different elements in data set, range difference may really affect your sorting algorithm. So this is it about comparison and non-comparison based data set. Most important points to keep in mind are, one is about time complexity. Non-comparison based can beat comparison based sorting in time complexity. Second thing is that range of values can affect non-comparison based sorting, but in case of comparison based, range doesn't matter.